Alright, this next video is going to talk about factoring some special patterns, some special factors. So in some cases, if there's a specific pattern, you can basically follow a rule that will tell you how to factor it. In this case, we're going to talk about three different patterns that involve either perfect squares or perfect cubes. So the first pattern I'm going to talk about is one you've probably used in the past in Algebra 1 and Algebra 2 called difference of squares. So the idea is if you have two squares that are like one subtracting from the other, so like a squared minus b squared, this can be factored into a minus b times a plus b. Okay? So as long as both terms are perfect squares, this will work. So like in this first example here, I got 4x squared minus 25. So both of these are perfect squares because 2 squared is 4 and 5 squared is 25. So in this case, like your a would be 2x and your b would be 5. Okay? Because 2x squared is 4x squared and 5 squared is 25. So following the pattern above, you can factor 4x squared minus 25 into 2x minus 5 times 2x plus 5. And that's it. This might be a good time to point out that when you factor, order doesn't really matter. So if you would put, say, 2x plus 5 first, then 2x minus 5, it doesn't make a difference. It's the same thing because when you multiply, order doesn't make a difference. Okay, so this pattern is called the difference of squares because you're subtracting two squares, difference of squares. There's two other patterns involving perfect cubes that we're going to talk about also. There's the sum of cubes and the difference of cubes. So sum of cubes looks like this. So it happens when you have two perfect cubes adding together. So like a cubed plus b cubed. Okay? So in this case, here's how it can be factored. So if you have a cubed plus b cubed, it can be factored into a plus b multiplied by a squared minus a times b plus b squared. So a cubed plus b cubed can be factored into a plus b times a squared minus a times b plus b squared. Right? There's also one called the difference of cubes. So if you have a cubed minus b cubed, this can be factored into, it's very similar to this one. So the first difference is instead of a plus b, if it's minus, you start off with a minus b. And then the other parenthesis also similar with one difference. So it starts off with a squared again, but instead of minus ab, if it's a difference of cubes, this middle term becomes plus ab, and then it's still plus b squared on the end. Okay? And that's it. So if you look down here, I've got 27x cubed plus 8. So this represents a sum of cubes because both 27 and 8 are perfect cubes because 3 cubed is 27 and 2 cubed is 8. So in this case, your a will be 3x because 3x to the third power is 27x cubed, and your b will be 2 if you want to follow along in the pattern. So now all I got to do is plug these into the pattern and I'm pretty much done. So I start off with a plus b. So I start off with 3x plus 2. Then it's a squared, so it's 3x squared minus a times b, so minus 3x times 2. Okay, then plus b squared, so plus 2 squared. Now all you got to do is simplify. Okay, and you can do this right away. You don't have to break this down into 2 steps, but I just wanted to do it, break it down for you the first time. So 3x squared, if you take 3x squared, you're going to end up with 9x to the second. 2x or 3x times 2 is minus 6x, and 2 squared is obviously just 4. So there I have a sum of cubes that are broke down into 2 factors. Okay. Now down here, I've got y cubed minus 64 z cubed. So this is a difference of cubes. Okay, so y cubed is obviously a perfect cube, and 64 z cubed is a perfect cube because 4 to the third power is 64. So in this case, your a will just be y, and your b will be 4z. Okay, so if you use this difference of cubes, so I start off with a minus b, so I start off with y minus 4z. Okay, then I have a squared, so I've got y squared in this case, plus a times b, so plus y times 4z, which will just be 4, I can't really multiply anything together because it's not the same variable, so 4zy. And then finally plus b squared, so plus 4z squared, which I'll simplify right away. It'll just be 4 times 4 is 16, so it'll be 16z squared. And that is a difference of cubes. Okay, so kind of a way to remember the pattern is if it's sum of cubes, it's a plus in the first parenthesis and a minus in the second, and then if it's a difference of cubes, it's the same pattern, just this minus and plus sign are kind of flip-flopped. Okay, but if you ever see any difference of squares, sum of cubes, difference of cubes, all you have to do is remember the pattern, and the factoring kind of takes care of itself.